Hello everyone, my name is Marwa Kutub. I am a programming tutor and my course is Introduction to C++ Programming. It's a 10 weeks self-paced non-credit course intended for non-programmers. It provides learners with a solid introduction to programming using powerful, fast and popular C++ programming language. The course assumes no prior programming experience. However, the learner should be familiar with the basic computer tasks, such as using the internet, installing and using application programs, downloading, unzipping files, and so on. For student supports, there are a few that I would like to highlight. For that, I'll take you into the course content. At the beginning of the course, I have developed an orientation video to create a warm and inviting atmosphere for learners and to get them to be familiar with the module's main content. Another important feature is contacting your facilitator page. I offered in this page virtual office hours where learners can get to meet me synchronously at designated times via Skype. Skype is equipped with a screen share feature which provides opportunities for learners to show me their codes, and I'm gonna help them to correct these codes live. Programming can be stressful to some. It's important for educators in our field to address the dilemma of programming anxiety. To do that, I integrate games in face-to-face classroom. For this online environment, I've provided a page and called it Learning to Code Can Be Fun. In this page, I have given a list of interactive games that teach complex programming concepts in an entertaining manner. Although these games are intended for teaching coding to youth, yet I believe they can highly support adults as well. For this course, I have 8 modules. I have completed only the first 3. For each learning module, I start with the bridging statements to ignite curiosity and to reinforce that the concepts of each module are connected to previous knowledge. Then I articulate the learning objectives, learner goals, and the learning tasks of the module. Finally, I provide the set of resources and activities of the module. In the first module, the learners are supposed to identify the software development phases, use design tools, algorithms, and flowcharts, identify the fundamental parts of C++ program, and compose the output statement using the cout statement. If I went all the way down to the resources and the activities, the first task implies the learners to watch a video about the software development cycle. Followed by that, readers are supposed to read a tutorial about using algorithms and flowchart to solve a programming task. Then the learners are required to complete this learning activity. All the instructions are given in this document, where learners are supposed to write an algorithm that moves a robot into the maze until they reach the ending point. Learners are supposed to discuss their solution in this forum. They are asked to post their suggested solution even if they are not sure if it's correct or not. They are also asked to look into the solutions of others and outline their thinking on these solutions. They can refine their solution if they want to and repost it again. After that, there are a couple of resources, a video and a tutorial that are provided to cover the learner course, the rest of the learning course, fundamental parts of C++ and the cout statement. Followed by that, I have created a demonstration video for a practice question provided in tutorial number 2. At the end of tutorial 2, and then the students are given a self-check quiz that help them to assess their learning of tutorial 2. The quiz is not part of their evaluation plan. However, they will receive a grade out of 5 for their own purpose only. Let me show you the quiz here. It's a multiple choice quiz formed of 5 questions, as you can see. Now students are ready for lab, where they need to apply knowledge and use the concepts they have learned in this module to develop solutions for programming problems. This is the lab problem set. Again, there is a discussion forum for the problem set of Lab 1. I will be part of this discussion forum. At the end of each discussion, I will provide a summary of the posts as well as model answers to the problem set of the lab. There is an assignment for students to complete at the end of this module. Again, here the assignment focuses on enhancing problem-solving skills and solving programming tasks. Now it's time for the summary for Module 1 summary, where students are given an infographic that have the main concepts that have been explained in the module. The last thing of this module is a minute paper, where students have the opportunity to reflect on their learning in this module. Assessment techniques in this course are well aligned with the course content and the course objectives as well. Besides giving learners the chance to apply knowledge, they aim to enhance problem-solving skills and prepare learners to work environment where collaboration and teamwork is the norm. In both modules, the self-check quizzes had questions that contain a set of codes to trace and find output for, as well as codes that contain syntax and logical errors where learners had to correct. And hence, the multiple choice questions weren't there to assess recall and comprehension. On the contrary, they were there to promote and assess higher order thinking. The programming task incorporated, as well as the lab problem sets and the assignments, they all have been used to help learner to assess deep learning, as well as enhance problem-solving skills that is essential in programming. Well, the most difficult for me was developing lesson plans. I had to visualize how would the course look like when I've never developed any online courses before nor used the Moodle. At many points, I wasn't sure if I could implement a certain activity in the way I designed it. So I would search the implementation and see the options of the Moodle and then get back and alter the task in the plans to cope the implementation options. Another issue was implementing my demonstration videos. From one side, I'm not comfortable typing myself, and from another, English isn't my first language. At earlier stages of implementation, I considered using text-to-speech technology. That is quite easy to integrate while screencasting. But as an online learner, I have personally witnessed how personified screencasting created by my educators in various programs embed humanization, and hence I decided to be heard via demonstration videos. One of the things that really surprised me while developing this course is my ability to develop course design components. I've worked for a long time as a lab assistant under the umbrella of my professors, and hence I haven't been involved in course design components. I'm new to developing course plans, syllabus, quality checklists, evaluation plans, and many other things. Frankly, I had doubts I would be able to accomplish design components efficiently, and I'm so proud of all the design components I've developed in this course. The other thing that really impressed me is to deploy an online course for such a complex practical subject matter. I know there are plenty of courses out there in the market that have well-developed videos and equipped with advanced tools. But that's not what it takes to really learn to code. Learners must be engaged into activities where they discuss, agree, disagree, reformulate, and synthesize their thinking. During implementation, I tried to give supports and design activities that mimic such interactions. I believe there is still more to make things better, but I am satisfied of what I accomplished thus far. For me, one of the most major obstacles that I had to overcome is technology selection. There are a wide variety of educational technology tools in the market right now. Making the right decision as to what matches the subject matter without being distracted is quite tough. I had used the sections model that I've learned about in EDUC4152 to assess technology integrated in this course. My thinking has changed in many aspects, starting from the educator role, where I realized it's not only about developing course content or providing support when needed. I get to understand now it's more about modeling behavior, facilitating sharing and participation, and creating and maintaining community. During the program and in the course development phase in particular, I have come to see that effective course design and development must be associated by the right map, which is the quality checklist. These lists aren't just those boxes being ticked to ensure the presence of quality aspects. Moreover, they will be assessed, altered, and updated as a result of developing and teaching processes. The last change has to do with my recent peer review experience. We tend to prefer to have a peer review from experts or educators of our fields. But my recent peer review experience has showed me that peer review of educators outside our field can even be more effective. Besides judging instructional aspects of the course, these educators can review the course with the eye of the beholders or the learners, which can certainly help to develop a better course.